Hello and Assalamualaikum. Today we will love to present our group project entitled Sentiment Analysis of SONY XM5 Headphones. Next, introducing our team members. Moving on to the introduction of our group project, the WH-SM5 is a high-end wireless headphone known for its superior noise cancellation, comfortable design, and also clear call quality. It also features dual processors and 8 microphones that adapt to the user's environment through a feature called Auto MC Optimizer. So, into this digital age, online reviews have a huge impact on consumer decisions. However, these reviews are often unstructured and also overwhelming to go through manually. Thus, our project uses sentiment analysis, which is a natural language processing technique to extract opinions from these reviews. So, the goal is also to build a machine learning model that actually can classify these reviews, hence providing insights into customer satisfaction and also product performance. From here on, the problem statement of our study is to identify that one of the main challenges consumers face is the confusion caused by mixed and conflicting reviews. Some users praise the product, while others have concern about aspects such as price or connectivity. So going through hundreds or thousands of these reviews manually can be time-consuming and also ineffective, especially when trying to decide on a purchase. Hence, additionally, it's often difficult for users to tell whether a review is genuinely positive or negative due to various wording styles and also personal biases. So, this will lead us to the objective of our study, which first of all, we need to identify and analyze the customer review trend and also to evaluate the best model in predicting these customer reviews. So our study will involve some data scraping, analysis, and also visualization, which will be explained throughout this presentation.
Now, let's continue with background of study, which focus on sentiment analysis, a key area within natural language processing or NLP. Sentiment analysis, often referred to as opinion mining, involves detecting and interpreting opinions, emotions, and attitudes from text data. This field has grown rapidly in response to the explosion of user-generated content on platforms such as social media, online review sites, and e-commerce platforms. According to Liu and Zhang from 2012, the central aim is to classify sentiment into categories such as positive, negative, or neutral. In its early stage, sentiment analysis primarily relied on lexicon-based methods. This approach used predefined dictionaries of words with assigned sentiment values. They are appreciated for being transparent and easy to interpret, but they often fall short in terms of accuracy, especially with large or domain-specific datasets. This is the segment from Studies Method from 2014. As the field matured, researchers began adopting machine learning techniques. These models learn from labeled dataset and offer improved classification performance, though they can be more complex and harder to interpret. More recently, deep learning and transfer learning models have significantly advanced the field. For instance, Scarf, Hans, and Ben Lien from 2022 found that models based on BERT and similar architectures outperform traditional approaches by over 20 percentage points in classification tasks. However, this improvement in accuracy comes at a cost, primarily complexity and reduced interpretability. The choice between accuracy and transparency has become a recurring theme in current sentiment analysis research. Sentiment analysis has broad applications across industries. In marketing, it helps companies monitor customer satisfaction. In politics, it used to gauge public opinion on policy or candidates. In finance, investor sentiment, as captured from news or social media, can even influence stock market trends. A recent study by Sharma from 2024 revealed how sentiment shifts with time. Their research showed that positive sentiments rise during seasonal sales on e-commerce platforms, providing key insights for business to adjust marketing strategies. Despite its progress, sentiment analysis still faces several challenges. Ravi from 2015 point out that current models often struggle with sarcasm, irony, and informal language. Zhang, Wang, and Liu from 2018 highlight the role of deep learning in addressing some of these issues, but much work remains. Further, Zhao Reshuk and Zhao from 2021 evaluate a wide range of sentiment tools and found that performance can vary depending on the dataset and the model architecture used. This suggests a continued need for models that are adaptable and robust. To summarize, sentiment analysis is a fast-evolving field with significant practical relevance, while lexicon-based and machine learning methods laid the foundation. Recent innovations in deep learning have propelled it forward. Still, issues of interpretability, dataset variability, and linguistic complexity remain central concerns. This background sets the stage for our own investigation as we seek to contribute to the growing body of knowledge in this area.
I'll be presenting the methodology. First, we will look at the data understanding. The product that we choose is SONY WH1000 XM5, and the website is from Google. And then we obtain 6 attributes and 1,269 data. And this is the data description. First variable is the review title, which is the title of the review. And the second variable is item, which is the model of the headphone. The third variable is date, which is the date the review was published. And the fourth variable is username, which is the reviewer's username. And the fifth variable is country, which is the origin country of the reviewer. And the last variable is review text, which is the full context of the review. Moving on to the data dictionary, we can see that 5 variable is string data type, which with only date variable with date data type, and the level of measurement of the 5 variable is nominal, with the date variable is interval level of measurement. Okay, we will move on to the data source. First, to scrape the website, you need to download Data Scraper extension to Chrome. You can find this instant data scraper on Google Play for Windows. And then you need to download it and add to Chrome. After you have downloaded it, you need to go to your desired website to scrape reviews from. In this case, we choose Sony Malaysia. We search on Google Sony XM5, and we found this Sony Malaysia website with 1,900 plus reviews. And we click on the website. We can see the reviews from the customers. So we need to click on the reviews to show the description of the reviews and all the context of the reviews. And we click show more reviews for all the reviews that we want to scrape. And then we clicked on the extension, which is the instant data scraper, after we have shown all the reviews that we want to scrape. And then we can save the file in Excel. Moving on to the data preprocessing, we can see that before it contains 31 columns, and the attribute name is not suitable, and it contains symbol, and there is 70 missing values in username column. And therefore, we remove a lot of columns and only retain 6 columns out of the 31 columns, and replace the attribute names, which we can see here, which is the review title, and item, date, username, country, and review text. And then we remove the symbols. We can see more clearly in the next slide. Here you can see that before the variable country, it was named IT35, and there is parentheses in the data. And so we remove the parentheses, and you can see the missing values in the column username. So we replace the missing values with anonymous 1, 2, 3, 4, 5, 6, 7, 8, and until the missing values is all replaced.
To achieve the first objective,
we need to have the sentiment of the customer reviews. Firstly, we retrieve the clean data using a retrieve operator. Next, nominal to text operator was used to convert all nominal attributes to string. Next, the sentiment of the reviews was extracted using extract sentiment operator and creating sentiment score. To store the sentiment in a new column, a generate attribute operator was used. After that, the good and bad reviews were labeled using set role operators. And finally, the data with their new generated columns were wrote to Excel using a write Excel operator. So, this is the new data set with two new generated columns, which were sentiment and score. Next, we proceed to the descriptive analysis. The pie chart indicates that the majority of customer reviews are good, with over 85%, while only a small portion, about 15%, are bad reviews. The bar chart highlights the customer reviews over year from 2023 to 2025. It shows that 2024 had the highest volume of customer reviews, both good and bad. While good reviews consistently outnumber bad reviews across all years, 2024 saw a spike in overall engagement. In 2025, although positive reviews declined, the proportion of bad reviews also slightly dropped, indicating possibly fewer but more favorable interactions compared to 2024. Lastly, this chart shows total customer reviews by country. United Kingdom dominates in customer engagement, contributing the bulk of the reviews. In addition, USA, Malaysia, and Singapore follow with moderate levels of reviews. Meanwhile, countries like Philippines, Thailand, and Indonesia have minimal representation in customer feedback. This distribution can help businesses understand where their customer base is most active and identify regions with potential for growth or improvement in engagement.
For this predictive modeling, the process began with data pre-processing, which included cleaning the dataset and preparing it for analysis. The modeling and validation process followed the same process for all three techniques, which are naive Bayes, decision tree, and subvector machine SVM, with the only difference being the classifier used within the cross-validation node. In the overall training process, the dataset was first retrieved, and the target variable, which is the sentiment label indicating whether a review is good or bad, was set using the set role node. The nominal to text node was then applied to convert nominal data into text format to ensure compatibility with text processing operations. Next, the process documents from data node was used, which included several key steps, which is tokenization to split each review into meaningful word units, then filtering English stop words to remove common words such as is, are, and the, and stemming using the Porter algorithm to reduce words to their root form for better analysis accuracy. Then, the cross-validation was performed using 10 folds to ensure a reliable and robust evaluation of each model performance. For the naive Bayes model, the naive Bayes operator was placed inside the training subprocess, while apply model and performance node were used in the testing subprocess to handle prediction and accuracy evaluation. For decision tree, the parameters were set with a maximum depth of 10, a minimum split size of 4, and a confidence level of 0.5. For SVM, the kernel type was set to dot, the kernel charge to 200, the convergence epsilon to 0.001, and the maximum number of iterations to 100,000. Next, we move on to the confusion matrix. The result from the cross-validation showed that naive Bayes achieved an accuracy of 70.6%, decision tree achieved 100%, and SVM achieved 86.13%. While decision tree showed perfect accuracy, this result is a strong indicator of overfitting. In sentiment analysis, the decision tree often overfit because they create highly specific rules based on individual words or phrases in the training data. Since text datasets have a very high number of sparse features, the model tends to memorize these details rather than learn general patterns. which leads to excellent performance on training data but poor generalization to unseen reviews. SVM, on the other hand, performed better due to its ability to handle high-dimensional data, which is common in text classification. Furthermore, its kernel-based approach allows it to model complex and nonlinear relationships in the data, making it highly suitable for sentiment analysis. To achieve Objective 2, evaluating the best model, SVM was chosen as the preferred model due to its high accuracy and better generalization ability compared to naive Bayes and decision tree. When further tested, the SVM model achieved 94.8% accuracy, indicating strong performance and reliability in classifying customer reviews. With accuracy above 90%, SVM is considered well-suited for practical application in sentiment analysis, providing valuable insights for business to understand customer opinions.
In conclusion, the analysis of customer reviews for the SONY XM5 headphones highlights a clear and consistent trend of positive sentiment over the years. This strong customer perception not only supports potential buyers in their decision-making process, but also reinforces the product's credibility in the market. Furthermore, the solid customer base offers Sony valuable insights, enabling the company to explore new market opportunities while continuing to prioritize and enhance customer satisfactions. Overall, these findings underscore the importance of customer feedback as both a marketing asset and a strategic tool for future growth.